Okay, it looks like it finally arrived. Let's see what's in here. I have a suspicion, I think I know what this is, but... Oh, yes. Exactly what I've been waiting for. Look at that. These are... There. I ordered a bunch of them. Tunable RF variable capacitors. Okay. So it's got the 2 leads, 3 leads I guess. I'm not sure why it's got 3. We have to do some investigation. And a little knob you can twiddle here. So if we want to make some tunable stuff, why not just make it a high power oscillator, right? Of course, I'm not sure what kind of voltage these things can hold off. But yeah, we'll do some measurements on this. We'll see what kind of capacitance we get out of these. Maybe I'll do some voltage measurements, but I may not. I don't know. I don't want to break these. We could fill them up with oil, and that would increase the dielectric and the breakdown potential. I don't know. We'll see. I'm going to fiddle with these. I got some interesting experiments we're going to do with those. Okay. Okay, so we're going to test our little RF capacitor here, variable capacitor, and we have our LRC meter here, and I just have one hooked up here, and see it's got 3 leads on it, and for some reason I'm not sure what the other lead is, but I've tried all combinations, and the only really useful ones are the center one and this one off to the right, which is the way I got this guy hooked up. And so looks like at the low end it's about 16 picofarads, and then if I turn this, you got to be careful when you're touching it. It actually changes the capacitance, so I may have to put a dielectric rod or some kind of knob on there or something to twiddle with it, because it will affect the capacitance when you touch it. At least it was earlier. Maybe this pin doesn't so much. Well, I guess it was minimal. Still be good to have a knob on it. Anyway, so we'll twiddle with it a little bit more, and we'll see what the upper end of this guy is. Okay, so we've turned the knob all the way. Would that be counterclockwise? Okay, so that's 74 picofarads. So the high end 74 picofarads, and the low end is 16. And so I have a project already to use this guy, because our Tesla coil, according to my calculations, needed an input of about 30 picofarads to get it in tune. So we might use one of these guys to tune up our solid state Tesla coil, which would be a separate video. Anyway, looks like this is going to be a handy little device. Not sure what the breakdown voltage is. Okay. So anyway, okay, so I have my neon light here. I don't know if you can see that very well. Oh, must have gone out. Okay, it's right there. And I have my tunable capacitor here, hooked up near this coil. And I soldered the leads onto the primary. And so let's, I have the scope tuned in to the resonant frequency, which is about 284. And let me just, I'll turn off this light here, and I'll just start twiddling with the knob here, and see if we can bring this guy into resonance by twiddling. See, I can increase and decrease the power output here just by twiddling with this capacitor down here. Okay, I guess we're out of resonance now. Let's... Oh, what happened? Oh, our clip lead came off, that's why. I'm sorry. Okay. Let me tune this guy back in. Okay, so there's our resonance. See if I can tune it in like so. He's just capacitively coupled to this coil, and then other lead is hooked to the ground of the coil. Okay, so we'll get the frequency tuned in, and then I'll twiddle with our capacitor down here, and see I can improve the match or make the resonance go away, so we can get more power out of our coil by matching the primary and the input. Okay, see that? The LED is glowing, or the neon light is glowing a lot brighter now. And all I'm doing is I'm just twiddling the variable capacitor here. So anyway, very interesting, huh? I don't know what kind of voltage we can stick on those, but for low power solid state Tesla coils, it looks like this might be a good way to match the primary. And this is Dr. James, and thanks for watching.